Hey there, and welcome. You have definitely seen this thing everywhere, on the back of trucks, on tanks, on the doors to labs. That super colorful diamond symbol. But what is it actually telling us? Well, today we're going to decode this universal language of chemical safety. No, seriously, think about it for a second. You've probably driven past this symbol 100, maybe even 1,000 times. It's designed to give firefighters and other emergency responders a super quick, at-a-glance summary of a chemical's dangers. So let's break down exactly how it works. All right, so its official name is the NFPA 704 Hazard Diamond, and it comes from the National Fire Protection Association. They created it to be a standardized, crystal clear way to communicate hazards immediately. You know, the easiest way to wrap your head around it is to think of it like a nutritional label on your food. But instead of telling you about calories and sugar, it's giving you the lowdown on health risks, flammability, and reactivity. Okay, so the whole code is really in the colors. The diamond is split into 4 sections, or quadrants, and each color tells a completely different story about the kind of hazard we're looking at. Let's break them down one by one. First up, we've got the blue quadrant. This one is all about health. It basically answers the question, if you get exposed to this substance, how much trouble is your body in? How much harm could it do? Next is the red quadrant, and you can probably guess this one. It stands for flammability. This section tells us just how easily the substance can catch fire and burn. A high number here is obviously a massive warning for firefighters. The yellow quadrant. This one is all about instability, or what scientists call reactivity. It's answering the question, how likely is this chemical to, explode or react violently if it gets dropped or heated up or mixed with water? And finally, down at the bottom, we have the white quadrant. This is kind of like the special notes section for specific hazards that don't really fit into the other categories. You might see a W with a line through it, which means do not mix with water, or maybe COR for corrosive. Now, inside each of those colored sections, you're going to see a number from 0 to 4, and this simple rating system tells you how severe the hazard is. 0 means pretty much no hazard, while a 4, well, a 4 means the danger is severe and could even be lethal. It's simple, it's clear, and it's incredibly effective. So we know what the colors mean, we know what the numbers mean, but where do those numbers actually come from? This is maybe the most important part of this whole thing, because getting it wrong can have, well, really serious consequences. The answer is a document called the Safety Data Sheet, or just SDS for short. This is the official, legally required document that comes from the chemicals manufacturer. It is this single, non-negotiable source of truth for all this hazard info. And here's the crucial point, so listen up. You have to use the official SDS from a reputable manufacturer. Searching for the chemical name plus SDS will almost always get you to the right PDF document. What you absolutely positively cannot do is just go to Google Images or Pinterest or ask an AI to make one for you. Those can be outdated, wrong, or just completely made up. Right, so think of the SDS as the chemical's user manual. It has literally everything you need to know to handle it safely. They're usually pretty long documents, but for our purposes, we only need to focus on a few key sections to find the numbers we're looking for. So first, you'll want to check Section 1, just to make sure you've got the right chemical. Section 2 gives you a quick overview of the hazards, but the real treasure, the numbers we need, are almost always hiding in Section 16, which is usually labeled Other Information. That's our target. Okay, this is where it all comes together, the fun part. Once you've navigated that SDS and pulled out the data, you have everything you need to build an accurate and, frankly, life-saving symbol. So let's walk through a quick real-world example. Let's use acetone, a really common solvent. After finding its official SDS, we jump to Section 16 and we find these ratings. Health is a 1, flammability gets a 3, and reactivity is a big fat 0. And there are no special hazards to note for this one. And these numbers we just pulled from the sheet, they aren't just abstract data. They are the exact values we're going to use to build our diamond. So we take our diamond and we just plug in the numbers into the right colored sections, a 1 in the blue, a 3 in the red, and a 0 in the yellow. We also add the name and maybe a key safety warning, and boom. Now anyone can see at a single glance that acetone's main danger is that it's highly flammable. Now look, this whole process is not just some neat little classroom exercise. The real-world stakes here are incredibly high. Scientific accuracy isn't about getting a good grade on a lab report. It's literally about protecting people's lives. And when it comes to safety, the data is what matters most. I mean, look at this. A full 70% of what makes this symbol useful is based on getting the labels and the data exactly right. The accuracy of those numbers you pull from the STS is everything. It's the entire foundation of the system. At the end of the day, every single person, from a scientist to a technician to a first responder, relies on this information being correct. An inaccurate label can lead to someone handling something the wrong way, which can cause dangerous reactions and really serious injuries. Getting this right is a fundamental responsibility. So if there's one thing you take away from all of this, let it be this. In science, accuracy is safety. The care you take to find and represent that data correctly translates directly into a safer world for everyone. So next time you're on the highway and you pass a tanker truck or you walk by a lab, take a look for that diamond. What are you going to look for first? Which color, which number will catch your eye? Because now you have the tools to read the story it's telling. Thanks for tuning in.